Welcome to this tutorial on safety using control flow with Pact. While Pact is already a simple and safe language for smart contracts, there are a few patterns and recommendations you can follow to make it even simpler and even safer. Throughout the next few tutorials, we'll discuss a few of these patterns. In this tutorial, I'll cover each of the following topics. First, I'll start by introducing control flow with Pact, and afterwards, I'll walk through a code demonstration, including 2 examples of rewriting code to follow our safety best practices. In one line, the key idea for this tutorial is that when writing Pact smart contracts, avoid using if statements. Instead, use enforce to ensure your code is both simple and safe. So let's go into more detail on this idea. Control flow is the order in which individual statements, instructions, or function calls are evaluated. Using Pact, you can use either if or enforce as a means to control the flow of your application. While you can technically use either, we recommend using enforce whenever possible. Using if is considered harmful to the application. As a quick recap, here's an example of an if statement using Pact. In this case, the statement is checking whether 2 plus 2 is equal to 4. In this case, it's true, so it would return the phrase, "Don't use if statements." This is simple, but with if statements, each new branch makes code harder to understand, opening up the possibility of bugs in your application. Here's a bit of Pact history. Pact's original design left out if altogether, along with looping, but it was decided that users should be able to use these features as they need. So that's why we both have it and suggest that you don't use it. That's because enforce is a safer option that allows you to remove potential logic branching. Here's an example of an enforce statement using Pact. Similar to before, you're checking that 2 plus 2 equals 4 and returning a value. Next, here's another important difference between if and enforce to keep in mind. If statements run code and result in either 2 different outputs, depending on the condition. In this case, passing will result in output 1, and failing will result in output 2. With enforce, there's only one possible output, and you'll get that result in the case that the code meets the conditions set by enforce. In the other case, the code fails, and what you get back isn't a separate output, but a failure message. This is different from an if statement in that no code is run and there's no output, just the failure message. If you'd like, you can view more about control flow in our documentation. Next, you'll walk through a smart contract demonstration that uses if statements. You'll then refactor these to use the safer option, enforce. For this demonstration, we built a smart contract named MyCoin. This project represents a simple ledger system providing transfer, credit, debit, account creation, and querying. The goal of this demonstration is to develop a smart contract that adheres to the best control flow safety practices. To start, open your terminal and change into your project directory. Clone the project repo found in the pactlang org code directory. Next, change into the control flow project directory. And finally, open the project in Atom. Within this project, you'll see both the mycoin.pact and mycoin.repl files. In mycoin.pact, you'll see both unsafe and safe alternatives for this program. You can view the completed files in the complete folder and the code challenges from within the challenge folder. I'll work through the challenge folder and demonstrate the 2 examples from this file. First, by writing the unsafe alternative using if, and then by writing the safer alternative using enforce. Starting in the debit if function, you can see that there's an opportunity to use an if statement. Taking a step back, you'll see that this function is meant to debit a certain amount from an account balance while recording both the date and data. The opportunity for the if statement is at the point where we need to check if the balance is sufficient for the transfer. As you'll see, we want to check that the amount being transferred is greater than the balance. A perfectly unsafe way to do this would be to write an if statement like this. If the statement is true, meaning the balance is sufficient to make the transfer, the if statement will go on to update the account from within the mycoin table, like this. If the statement is false, meaning the balance is insufficient to make the transfer, send an error message, like this. And here's a look at the final code. Hopefully you get the idea of how this works, but feel free to pause and work through the details if you'd like. The key idea here is that this is a clear case where it feels like if makes sense to use within your code. The problem is, for reasons mentioned earlier, we'd like to remove if from our code in favor of enforce. So let's refactor this code now. In this case, the function is similar, but we'll make this safe decision and use enforce. As you can see, you'll need to enforce the condition without using an if statement, then update the myCoin table as you had done previously. To start, enforce that the balance is greater than the amount being sent and fail the transaction if the condition isn't met. You can do that like this. This step is very similar to the if statement, but allows us to finish the function using simpler logic. Since the enforce statement handled the failing scenario, you can now write the update to the myCoin table account assuming that the enforce statement has passed. Update the balance of the account in myCoin table to be the balance minus the amount sent. By using enforce, you no longer need to create branching logic dependent on the outcome of the if statement. Again, take some time to make sure you're clear on how this code is working to better understand the function. Keep this pattern in mind and use enforce rather than if to create simpler, safer packed code. Next, I'll walk through another demonstration showing the difference between if and enforce. This is another situation where it may be tempting to use if. Though it's a similar idea, there's a few subtle differences in this demonstration that will be valuable to understand. So here's a look at the starting code. As you can see, you'll need to check that an account exists, update its balance if the row exists or if the key sets match, or insert a row if it does not exist. Each of these cases make it tempting to use if. For that reason, I'll walk through now coding each line using if statements. First, fetch all keys in myCoin table to see if the account exists. This is done by checking if the account contains a specific key within myCoin table. Within the if statement, check the key set and update the balance if it is found that the row exists. Do this by reading the myCoin table account and binding the balance and key set to the variable balance and returned key set. Then, if the key sets match, update the balance. This statement does that by checking if the returned key set value is equal to the key set value. If it is, update the myCoin table account to reflect the new balance by adding the amount to the current balance. Otherwise, don't update the balance and return that the key sets don't match. Finally, insert the balance and key set into the account on myCoin table. Looking back at the final code, you can see that this is working, but that it's using an unsafe if statement. This is causing logic that's more complicated than necessary and is something that would be better written using enforce. Take some time now to consider the code we wrote. Read through the comments in this file and decide how you might be able to approach writing the same logic with enforce rather than if. As you can see, you'll again need to check that an account exists, update its balance if the row exists, or if the key sets match, or insert a row if it does not exist. I'll go ahead and fill this out now. To start, you'll need to reorder the code slightly. You'll start by reading the myCoin table account, setting the default row balance to 0, and a key set at input key set. If the row exists, then bind the balance and key set value from the table. This is more efficient than the previous code and allows for a one-time key lookup. To compare, look back at earlier code you wrote. Notice how the code above is combining each of these steps by allowing for a single lookup. Next, use enforce to check that the input key set is the same as the row's key set. If not, return that the account guards do not match. Finally, write the account balance and key set to a row in the myCoin table. This section will use write to update myCoin table if the row exists, or it will insert a new row if it doesn't. Looking back at the final version of this code, you can see that we have completed the same logic without ever using an if statement. That said, there's one big difference. In line 96, the enforce statement will make the transaction fail, returning the failure message, account guards do not match. Previously, when using the if statement, the code transaction succeeds, resulting in an output string that includes a failure message. You'll see this difference shortly when we look into the REPL file, hopefully making it a little more clear. This, again, allows for simpler logic and can help you write safer code. Try comparing both versions of this code and ensure that you keep these patterns in mind as you write your own applications. And finally, here's a look at the mycoin.repl file. Here you'll see that the code is testing both whether the balance is sufficient and if the key sets match. Each of these include two versions, one to check the function using enforce, and the other to check the functions using if. You can run this REPL file to view the results of these tests. To do that, open the terminal and start packed. Next, load the mycoin.repl file. After running this command, you'll see the response from each of the tests that were run. That's one way to run the file, but before explaining this in more detail, I want to show you a great feature you can use from within Atom. Using the Atom editor, it's possible to see the output of these files without running the REPL file from the terminal. This helps make it more clear what's going on. To help with this, you can turn on the toggle trace feature, which is part of the packed language Atom package. I've turned this on, which you can tell by that the code is showing both blue and red dots, blue for passing code and red for failing. You can turn this on yourself by navigating to Packages, Packed Language, Toggle Trace, or by using the shortcode shown here. From there, you'll notice that on expecting failure, both functions using enforce, debit, and credit are a success. What that's saying is that these both failed, and what returned is a failure message. This is different than the functions using if, debit if, and credit if. In these cases, we were expecting failure, and this test failed. What this is saying is that the code passed and ran, which resulted in returning the string balance is not sufficient for transfer. The point I'm trying to make goes back to the graphic shown earlier. When using if statements, the code will always run, and in the case of a failure, you'll receive an output string containing the failure message that's a result of the code that was run. In the case of enforce, code that fails actually stops running code at all, and just returns a failure message. And that's what you can see here in this example. When using enforce, the code is actually failing, and when using if, it isn't. For now, that wraps up this tutorial on packed safety using control flow. Throughout this tutorial, you learned that using enforce can help make the control flow of your packed smart contracts even simpler and safer. You went over a few demonstrations teaching you ways to avoid using if statements in favor of enforce. This is one of the few key patterns that you can use to improve the safety of your smart contracts. Coming up, we'll go over a few more safety tips to keep in mind as you develop packed smart contracts.